Hello everyone, welcome to another episode of Automation Digest. Today we will be discussing a DSA problem called search insert position. This is an easy problem. The algorithm that we will be using here can be used in many problems similar to this. Here the question is, we are given a sorted array of distinct integers, which means there is no repetition of the number present in the array. We are also provided with a target value. We have to find out the index of the target if it is found. If not, we have to return the index where it would be present if it were inserted in order, which means assuming the example 1356, there is no target value 2. But if 2 was supposed to be inserted in this array, it would be inserted in position 1, which is in between 1 and 3. Hence, the output is 1, the index value of it. Whereas, if you find the target, as in example 1356, the target being 5, and because 5 is present at position 2, the output is 2. In the constraints, we have the limitations of the number and the length, and it is also mentioned that they are sorted in ascending order. With this information and the information on the editor, which is we will be provided with the number array called nums. We would also be provided with the target value in integer form, and we have to return int. Now, the most important part of the question here is we have to find this in O logN time complexity. With all this information in the question, let's try to solve this. First, brute force algorithm. Let's consider our first example where the array consists of 1, 3, 5 and 6 and the target is 5. Now, the brute force approach would be to search for the number or the target at every index. But with that, the complexity will become O of n. So how do we reduce it? First, we have to understand that O of log n is only possible when we divide the problem into smaller subproblems in every step, which means instead of iterating through every index of the array, we will only iterate through half of the array or even less. For this example, what we will do is, first we will consider our rightmost pointer to be at this location, which is 0, and the rightmost to be at the index length minus 1. Now, we will consider a mid value. The mid value will be this, or at one index, because on the left it is 0, on the right it is 3. Divided by 2 gives me 1. Now, considering this to be the mid, we will identify if the target is equal to this value, 3. We find out it is not. Now, we have two options. Either the target is lesser than this number or it is greater than that number. In this case, target 5 is greater than 3, which means that the previous number on the left will also be not equal to 5, or also not the place where 5 can be inserted. So even without checking the number, we can say that the number is not to be considered in this problem. My left, which was at position 0, straight away moves to mid plus 1. Because we have already considered mid, we are considering the next value to be the left. Now for this left being at 2 and my right being at 3, my mid will also be at 2. 2 plus 3 is 5, divided by 2 gives me a 2 in integer. Now we will check if the value at this mid, which is 5, is it equal to the target. In this case, we find out that it is. Because it is equal, we will straight away return the value, which is 2. Let's consider the other example. Let's consider the example 1356 and we have to meet the target 2. In this case, again, we start with the same formula of left being at index 0 and right being at index L minus 1 or length minus 1, which is 3. Now our mid is index 1. Now we compare our target with this value, which is 3. Is 2 equal to 3? No. Is 2 less than 3? Yes, it is. Because it is less than 3, even without comparison, this time we are removing everything on the right of 3, including 3, which means 3 was already compared, and we can safely say 5 and 6 cannot be equal to 2 or cannot be the order where 2 can be inserted. Now, my consideration only remains at index 1. My right straight away moves 1 less than mid, which is at 0 index itself. Again, both of the left and right being equal to 0, our mid is also 0. So we do a comparison here as well. Is the value at mid, which is 1, equal to 2? The answer is no, it is not. Is it greater than 1? Yes, it is. Because it is greater than 1, my left will now move to mid plus 1, which is at this location. As soon as this happens, we break the loop, because my left being greater than right is an imaginary situation. It cannot happen. Left has to be on the left, right has to be on the right. So as soon as my left is greater than right, we break the loop and we say 2 should have been inserted at location 1, wherever my starting index or left index is at. So my new array will become 1, 2, 3, 5 and 6. 2 being replaced in index 1. So let's code this out. The first thing is writing down the left and right. For the loop, we will continue till my left is less than equal to right. First thing that we do inside the loop is find the mid. Now for calculating the mid, we have written left plus right minus left by 2, because my left and right are moving. So if it is on the very beginning, which means left at 0 and right at L minus 1, it's easy. And at that point, right minus left is equal to right. There the formula becomes left plus right by 2, or simply right divided by 2. But if my left has moved from 0 to a different distant position, so while calculating the mid, we are supposed to subtract this value from our calculation as well, 0 to left. To subtract that value, we are adding minus left. Once we have calculated the mid, we have to see if the value at the index mid is equal to our target. If it is equal, we have to return mid. Else if the number at location mid is greater than target, or in other words, target is lesser than the number, which means everything on the right is not to be considered. So we will move the right to mid minus 1. If this is not the case, the only possibility that remains is target being greater than nums mid, which means everything on the left has to be negative. Once we come out of the loop, if we have never received the mid value, only then we will be able to come out of the loop. And if we do that, we will return the left value, because that would be the index where the value can be inserted. Now the time complexity for this code is O of logN. If I run this code, all my test case pass, and if I submit it, I get a runtime of 0 milliseconds, which beats 100% of the users. Also, the memory usage is 42.61 MB, which is pretty low and beats 97.24% of the users. A perfect solution for this problem. Also, the algorithm that we have used can be used in many other problems. With that, we'll end this session for today. Next time, I'll come up with another DSA problem. Till then, happy coding.